Statistics is the science of collecting, describing, and interpreting data. What is data? Data is a collection of recorded information. In statistics, the word data is plural for the word data value. A data value is a piece of information that describes something about a person, animal, thing, or place. If a person is left-handed, a freshman in college, and 55 inches tall, then left-handed, freshman, and 55 inches are all data values that describe that person. If a dog is a golden retriever, is 4 years old, and weighs 95 pounds, then golden retriever, 4 years old, and 95 pounds are all data values that describe that dog. If a car is red, gets 44 miles per gallon, and was made in 2004, then red, 44 miles per gallon, and 2004 are all data values that describe that car. A complete collection of data is called a data set. Let's say I'm doing a data collection project, and my goal is to record the grade levels and GPAs of 50 college students. After I record the grade levels and GPAs of those 50 college students, then those 50 recorded grade levels and 50 recorded GPAs would be my data set. Let's also talk about the meaning of an observational unit. An observational unit is a person, animal, thing, or place about which data is being recorded. If I ask a person, how tall are you? And the person says, I'm 55 inches tall, then 55 inches is a data value, and the person is an observational unit. If I put a dog on a scale, and I find out that the dog weighs 75 pounds, then 75 pounds is a data value, and the dog is an observational unit. If I measure the height of a tree, and the height of the tree turns out to be 72 inches, then 72 inches is a data value, and the tree is an observational unit. What does it mean to collect, describe, and interpret data? Collecting data means seeking out and recording data. People collect data to learn about the world. In class, we'll talk about some more specific reasons for collecting data. Describing data means summarizing data in a way that makes it easier for people to understand what the data is showing. Describing data can involve calculating averages, which we will call means in this class, or percentages. Describing data can also involve creating tables or graphs. Interpreting data means reaching a conclusion about what the data is showing. Let's say I ask 50 college freshmen, 50 college sophomores, 50 college juniors, and 50 college seniors how many hours of sleep they usually get each night. Once I have recorded their answers, I have collected a set of data. In my data set, I can calculate the mean, in other words the average, of each grade level by adding up their 50 answers and dividing the total by 50. I can then show the means of the different grade levels in a line chart. This graph will help me describe my data set. It will help me show how the number of hours slept per night by college students changes as they go from freshmen to sophomores to juniors to seniors. If my data set leads me to conclude that college students tend to start sleeping less as they move through college, then I have interpreted my data set. I have decided what my data set is showing. This is actually a made-up data set. We just have to pretend that this data set was recorded from 5 college students. In this data set, commute distance means the number of miles that each person commutes to school each day. These 5 people over here are the 5 participants. You could also call them observational units, but participants would be the more specific term. A participant is a human observational unit. This is what a data set usually looks like. Usually the data is entered into a computer spreadsheet with rows and columns. In a spreadsheet, each row contains data from one person, animal, thing, or place. In other words, each row contains data from one observational unit. If the data was collected from people, you would more specifically say that each row contains data from one participant. In a spreadsheet, each cell or box contains one data value. For example, right here, freshman would be a data value. And right here, 12 would be a data value. The title of each column is called a variable. A variable is something that can differ between different people, animals, things, places, or points in time. A variable is just something that isn't always the same. In this example, hair color is a variable because different people have different hair colors. College major is a variable because different people have different college majors. Grade level is a variable because different people have different grade levels. Number of siblings is a variable because different people have different numbers of siblings. Shoe size, account balance, height, and commute distance are also variables because not everyone has the same shoe size, not everyone has the same account balance, not everyone has the same height, and not everyone has the same commute distance. I said that the title of a column of data in a spreadsheet is considered a variable. However, the title of a column is only considered a variable if it's possible to get different data values inside that column of data. The reason why number of siblings is considered a variable is because different people have different numbers of siblings. What if I was asking these 5 people, how many birthdays do you have per year? And one of the columns in my spreadsheet had a title that said number of birthdays per year. Number of birthdays per year actually wouldn't be a variable. It would be a column in my spreadsheet, but it wouldn't be a variable. The reason why is because number of birthdays per year isn't something that varies across different people. Every person in the world only has one birthday per year. That means that no matter how many people I asked that question to, every person would tell me one. That means that number of birthdays per year actually isn't a variable. A variable is something that is able to vary. Something that isn't able to vary isn't a variable. That's why number of birthdays per year wouldn't be a variable. You might be wondering, if all 5 people told me that they have 4 siblings, would that mean that number of siblings isn't a variable? Number of siblings would still be a variable because even if all 5 people told me the same answer, it would still be possible to get a person with a different answer. If I ask a 6th person how many siblings do you have, I might get a different answer, even if all 5 previous people told me the same answer. In other words, even if all 5 people told me that they have the same number of siblings is still something that's able to vary. That's why number of siblings would still be considered a variable. Let's talk about 2 different types of variables. A quantitative variable is a variable in which each data value stands for the number of something or the amount of something. Let's look at number of siblings, shoe size, account balance, height, and commute distance. Let's look at those 5 variables. We can see that in these 5 columns of data right here, each data value stands for the number of something or the amount of something. Since that is true, we can say that these 5 variables up here are all quantitative variables. A qualitative variable is a variable in which each data value shows that a person animal, thing, or place is a member of a certain category. Let's look at hair color, college major, and grade level. We can see that in these three columns of data, each data value doesn't stand for the number of something or the amount of something. In these three columns of data, each data value shows that a person is a member of a certain category. For example, this data value right here shows that this person is a member of the category of people who have brown hair. This data value right here is showing that this person is a member of the category of people who are college sophomores. This data value right here is showing that this person is a member of the category of people who are psychology majors. Since we can see that all of the data values in these three columns show category membership, we can say that these three columns of data, we can say that these three variables are qualitative variables. Just because a column of data has numbers inside of it doesn't necessarily mean that the variable is quantitative. Imagine that I was asking these 5 people to tell me their student ID numbers. Student ID number actually wouldn't be a quantitative variable because a student ID number doesn't stand for a number of something or an amount of something. A student ID number is just a label for the student. Some types of numbers actually don't stand for the number of something or the amount of something. Student ID numbers are one example. Other examples could include social security numbers, jersey numbers, or driver's license numbers. Social security number, driver's license number, and jersey number wouldn't be quantitative variables because a person's social security number, driver's license number, or jersey number doesn't stand for the number of something or the amount of something. Social security number, driver's license number, and jersey number would actually be qualitative variables. If you think about it, a person's social security number shows that the person is a member of a certain category. The category is a category of one person. Also, a person's jersey number shows that a person is a member of a certain category. It just happens to be that that category only includes one person. Same thing is true about driver's license numbers. So, variables like driver's license numbers, jersey numbers, and social security numbers are qualitative variables because the data values are only labels for people, animals, or things. The data values don't stand for the number of something or the amount of something. Let's talk about 2 different types of quantitative variables. A quantitative variable can be either a discrete variable or a continuous variable. A discrete variable is a quantitative variable that has gaps between the possible data values, in which no data values can be found. Number of siblings would be a discrete variable because even though data values such as 1, 2, 3, 4, and 5 would be possible, it wouldn't be possible to have a data value between 1 and 2, a data value between 2 and 3, a data value between 3 and 4, or a data value between 4 and 5. For example, a person couldn't have 2.2 children or 4.1 children. Shoe size would also be a discrete variable because even though data values such as 10, 10.5, 11, and 11.5 are possible, it wouldn't be possible to have a data value between 10 and 10.5, between 10.5 and 11, or between 11 and 11.5. For example, a person couldn't have a shoe size of 10.75 or 11.25. Account balance would also be a discrete variable because even though account balances such as $3,000, $3,000.01, or $3,000.02 would be possible, no account balances between those account balances would be possible. For example, a person couldn't have an account balance of $3,000 and 0.017 cents. A continuous variable is a quantitative variable that has no gaps between the possible data values. In other words, a continuous variable is a quantitative variable that has a continuous or solid stream of possible data values. Variables such as height and weight are continuous. When you get your height or your weight measured with one of those old-fashioned scales, the scale moves continuously. In other words, it moves smoothly. It doesn't jump from one value to the next. Let's talk about two different types of qualitative variables. A qualitative variable can be a nominal variable or an ordinal variable. Let's talk about ordinal first. An ordinal variable is a qualitative variable in which the possible categories follow an order from lowest to highest. Grade level is an ordinal variable because the possible categories of freshman, sophomore, junior, and senior follow in order from lowest to highest. The opposite of an ordinal variable is a nominal variable. A nominal variable is a qualitative variable in which the possible categories don't follow in order from lowest to highest. College major would be a nominal variable because the possible college majors that we might record don't follow in order from lowest to highest. All possible categories are equal. Hair color would also be a nominal variable because the possible hair colors that we might record don't follow in order from lowest to highest. All categories are considered to be at the same level.